I am sitting in for Wayne Munson today. Wayne had a funeral to attend, and so I'll be your host this morning. Welcome to our webinar today. It's our privilege to have Dr. Scott Wells from the University of Minnesota with us. We do want to thank our sponsor, North Central Sustainable Ag Research and Education Group, for providing some of the funding for today's program through a SARE Professional Development Grant. So what we're going to do is, for questions, folks, there's a chat box on the right of your screen there, or if you're getting the full screen, you can go to the top and pull that box down, and there's a chat box there. So if you have questions during Dr. Wells' presentation, please type your question in. We will be going back over those questions at the end, just to avoid problems with audio delays that are normal with these sorts of venues. So again, I want to welcome Dr. Scott Wells, Assistant Professor of Agronomy and Plant Genetics from the University of Minnesota. He completed his PhD from North Carolina State University, researching weed suppression mechanisms of roller cover crops and organic corn and soybean systems. His current research program focuses on improving the yield and quality of forage production systems, including alfalfa, warm and cool season grasses, and small grains, along with employing a systems approach to improving both the economical and environmental sustainability of corn and soybean production in Minnesota. So with that, I'm going to hand it over to Scott, and thank you for joining us today, Dr. Wells.
Thanks, Kent. Do you want to go over these two slides too, or do you want me to do that, or you just did?
I can do that real quick. Thank you. We do have another webinar coming up Friday, June 30th at 11 a.m. on soil health for wildlife and fisheries managers. Why should one care? And I'll be presenting that, and that's supported again by the SARE PDP. And if you could go to the next slide, Scott. We also have two events coming up in August. The first one is August 8th and 9th from 9 to 4 in Faribault, Minnesota. It's more advanced soil health training with Dr. Ellen Williams. And then August 10th and 11th from 9 to 4 in Blue Earth, Minnesota. These are two different events, and you can go to our SFA website listed there for more details and registration. So please keep those on your calendar. Okay, thanks, Scott. Go ahead.
Thanks. All right, huge thanks to SFA for this opportunity. I've never done a webinar, and it's something I've always wanted to do. And also thanks to the participants today. It's beautiful outside, and I'm heading out to the field right after this. So I am Scott Wells, and I do have a lot of work going on, but today I'm going to focus predominantly around cover crops. And these systems are set up largely for the corn and soybean production systems, but that doesn't mean that they can't fit in wheat or sugar beets or name your crop. They work with animals as well, but I'm largely geared up around the grain systems for this research. All of this research in this proposal was funded by the Department of Agriculture's Clean Water and Land Legacy program, and along with some of it funding from the Forever Green program. And I'll get into some more details of Forever Green as we move in. So when I came to Minnesota from North Carolina, one of the senior faculty in the department handed me the value of wintergreen manure crops. And this is a 1936 extension publication, experiment station, publication from New Jersey. And in this publication, they talk largely about how they're able to, what do they need to do to get more out of their green manure. So not really even calling cover crops. But what's important about this publication is they talk about the total system. Animals, small grains, forages, some grain crops, some row crops, and it's this whole package. They're trying to figure out how can we get the total system productivity up. And they're dealing with many of the same challenges that we're dealing with today about risk, climate, weather risk, not getting the productivity out of our crops that we would like. And so, anyway, that production system would have looked largely like this Winnebago research area from 1941. And I counted, I think there's 8 or 9 different crops in this system. And I think that's an important point. These early management was largely about systems management in there. And as we fast forward 30 years down the road in the 70s, we see largely that diversity is replaced with corn and soybean. And this is nothing against corn and soybean. It's just it's the predominant two crops on our landscape. And there's a lot of other crops as well. I don't feel like I'm big favorites here. But so we have this corn and soybean rotation, and we know in Minnesota, I know this slide's a year or so old, this hasn't changed that much. We produce a lot of corn and soybean in the state. Roughly 8 million acres of each of them, and we produce them all the way up to the Canadian border. And so you have to wonder, with that level of production, if we think of that 1936 publication and the 1941 farm, and as we move to today, you have to wonder, what did we lose? Now, obviously, a lot of agricultural productivity. There's no doubt about that. But we have to wonder on the side of, was there consequences in moving this direction? And is there an opportunity to turn those consequences around for new opportunities? And that's really where my program is setting. It sets in these kind of, yes, I work in corn, yes, I work in soybean, but I'm really interested in those interfaces. Could we put cover crops in those systems? Could we put new crops in those systems? Could it be more perennial? And so that's what we're working on here, to try to get back some of those ecosystem services. Now, I like this slide because I think this conceptualizes the annual production system and probably anywhere in the U.S. And so what you'll see along the x-axis here, we have our seasons: summer, autumn, and winter. I kind of joked when I first put this together. There's no spring in there. It seems like in Minnesota it's just winter and summer. But anyway, there's so we have the 3 seasons, or 4 seasons, I guess one of them's covered up, and you have the green is your actual your crop productivity. So corn, soybean, wheat, you can name your crop, and it's positioned in time of year to intercept the maximum amount of soil irrigation, maximum amount of rain, and so on, to produce a lot of biomass. The problem comes in is that it only covers a short period, temporally 5 to 6 months out of the year, and so we have the red, and the red is where we're getting these losses of nitrate, phosphorus, soil losses, those consequences of not having a diverse cropping system. And I'm not going to belabor this. I guess maybe I will. There's 5 slides on it, so I'll try to keep it short. But we know that uncovered soils are susceptible to erosion, and most people are not surprised when you ask them, do you expect highly erodible lands to be susceptible to erosion? And they're like, well, yeah. But what about non-highly erodible lands? And so that's what this NRCS figure is showing. Each of those green dots are non-highly erodible lands that are highly erodible. And for each of the green and red dots, I believe it's 100 tons of erosion above the soil tolerance losses. So we need to be thinking a bit broader about how do we manage this loss of productivity. Losing soil is I like to think of it in some ways like losing future opportunity in it. And it's even worse than that because there's this whole jeopardy business with it, because if you've got nutrients entering your water or in your aquatic systems, it causes a lot of problems. Now, let's just, if I haven't convinced you yet that coverage is important, I think these next 2 slides will do it. So there's 3 figures here, and this is off of a Statewide program. And what they have here is on the x-axis for each 3 of these figures, they have percent coverage. So that would be like looking on the ground, looking across the field and asking how much coverage do you have there, and doing that visually. And what they saw was is that as coverage increased, as plants on the landscape increased, they saw a reduction in runoff, a reduction in suspended sediments, and a reduction in soil losses, all with having plants on the landscape. This is a more extreme example of some unpublished work that Dr. John Baker is leading in the USDA AURI program, where they looked at 69% slopes, and they looked at either having best management practices, which I'm coining here as conventional, or a continuous living mulch, which is a little different than this. It's a crop that would stay out there the entire year and persist with the corn. But what they saw was, in the conventional plots, and I think you can see the soil at the bottom of those catch basins, they saw anywhere between 4 to 10 tons of soil losses per acre. And that's fairly extreme. And then the ones where they had consistent coverage across the year, anywhere between 0 and maybe 2 tons losses on that. And so, again, this is an extreme scenario, but we do see slides like this picture here on the right. I see that when I drive around the state, and that's not 9 or 10% slope. So we really need to be paying attention to even lands that we don't think are highly erodible. Now, it gets a little more complicated, particularly on our corn and soybean land where we have tile drainage. And in the state of Minnesota, we know when our tiles are running. They're running April, May, and June. And this was some data from Giles Randall's 2003. So we have to think about this if we're going to try to deal with when we're getting the bulk of the rainwater or the water, the tile running system. What could we do in that system infield-wise to be able to manage some of this flow? It's not surprising that in May and June is when we're seeing the greatest running of the tiles, is when we're also seeing the most amount of nitrogen loss in the system. And so when we start thinking about a cover crop, well, when you want to plant your corn, well, you probably like me, you want to plant in April, mid-April, maybe soybeans at the end of April or first of May, and so you're trying to think, well, I've terminated my cover crop at that point. Am I really getting all the benefit? And we're getting benefit, but are we maximizing the benefit to off-site movement of nutrients? So not only do we know when the tile's running, we largely know where the nitrogen source of pollution is coming from. And this is a report from the Minnesota Pollution Control Agency, which states you see those 3 brown, yellow, and yellower, I guess, the crop groundwater, crop tile drainage, and crop runoff makes up about 70% of the nitrogen in our surface waters. And so, now, so we know when it's happening, and we know where the nitrogen is coming from. What can we do in these systems to not just remediate, but utilize that water, utilize that nitrogen? Maybe cover crops are a good fit in there. Many of us are aware, and I imagine most of the people on this webinar know that nitrogen and phosphorus entering our aquatic systems can create havoc, largely around reducing dissolved oxygen, as we see in this bottom slide here of the dead zone and the Gulf. And so we really want to use that nitrogen. So it's kind of like deals where you're losing the nitrogen off your farm that maybe you could use and export, but you also, the municipalities have to clean up, or we have to deal with the externalities of having the loss of these large ecosystems. So it's not just Minnesota. Minnesota is not the only one that's causing issues. That's why I showed these top 2. We need to be thinking about the entire Mississippi basin as we start trying to manage the movement of nitrogen from our cropland. And this is the trickier piece here, because the public looks to farmers, how the public thinks that they're causing their water rates to go up. They're farmers think, well, you're putting all this nitrogen into the environment, and so for where we're at the university, we're trying to figure out, well, we want to have ecosystem services to protect water quality. We also want to maintain agricultural output, and if not even increase that. And then there's also society. So trying to find a middle way in that is not easy. I think having new technologies to put on landscape and helping farmers, show that there are new ways could help in this. And one of the things that I hear sometimes, well, it's easy to think that these problems to water quality aren't in my backyard, and they actually are. And this was a paper that was coming out, a story that came out of the Star Tribune, which was showing that drinking water is costing Minnesota taxpayers millions. And so, when you start thinking about why, if you ask someone not from Minnesota, what's unique about Minnesota? It's the Land Lakes. There's all this water resources. Well, when you look at this figure at the top that shows total loading of nitrates in the system, so you wonder, well, if you can't access those waters for ecosystem services or for hospitality and things of that nature, that could be a significant loss to the state. And that's what this other panel is discussing from the Internal Revenue Service to Minnesota. They're showing over 2003 to 2013, close to $13 billion in tourism funds coming into the state. People coming to our state for natural resources. So you got natural resources on one side, and you've got agriculture on the other side. And what we're working hard is trying to identify that get away with it. Now, to kind of give you kind of a, I guess, the 30,000-foot view of this, typically in the state, we're planting our corn, soybean in April. These slides here are showing satellite imagery of green. So it's, if you're green, you're a plant, you're using nutrients, you're transpiring moisture, and if you're yellow or red, you're bare soil. And what we see in this system is that we're essentially green for about 5 to 6 months out of the year, and that leaves a lot of opportunities. And it's not just Minnesota. I think it's into Iowa and the Dakotas as well. And so the question is, well, what could you do? And I think plants can fit, and I'm not alone in this. And so recall from that earlier picture, the early figure I gave, where we have these opportunities for losses in the system. Well, there's a couple ways you could deal with this. One, you could plant cover crop. You could plant winter terminating cover crops. These are cover crops in panel B that you can see that you can plant behind your cash crop. They persist through the autumn and into the winter. Winter kill, and you'll have to deal with the residue in the spring and plant your subsequent cash crop. In addition to that, we have crops that survive the winter. These are ones like cereal rye or winter rye. You plant them up, they persist over the winter, they provide you soil service or soil protection in the fall, and then where it really matters is in the spring when it comes to water quality. That kind of gives you kind of an overview of what we're thinking about. We want to, so success in this program right now is to ask, okay, could we plant cover crops in the corn and soybean system? And what would be a real metric of success? And obviously, we can't have corn loss in yield or soybean loss. That's a given. But we're largely looking at, okay, we know when the tiles are running in the spring. We know when we're getting the nitrogen loss, when the nitrogen losses are maximized. We know we need biomass out there in the spring to be able to catch that nitrogen. So for us, success in this program is saying more biomass, looking at establishment pathways to enhance that biomass production, because plants use nutrients, they're using nitrogen. If they're using nitrogen, then you're getting less nitrogen moving through the soil profile, making it to the tile. That's kind of how we're structuring this. Really, it's about production of spring biomass on nitrogen resources. So, cover crop interseeding it's nothing new. This has been around for some time now, but it offers some unique challenges in the upper Midwest. And again, this is targeted around grain, corn, and soybean. We're doing in sweet corn, sugar beet, wheat. Those are a lot easier to deal with due to the timing, when the crops are off the field. But if you're in full season corn and soybean, not a lot of time in the back end of the calendar to get these cover crops planted. There's been a lot of work done on aerial seeding because aerial is really fast. However, some of the success level, like a lot of this, the success is largely dependent on rainfall. There's been some work that looked at a large meta-analysis that asked, okay, if you needed warm and wet to be able to make a cover crop take in the fall, what is the best state to live in this left panel? And it looked like Illinois, Ohio, Indiana, because they tend to get enough rain and enough warm to really make the aerial program work. For us, the research is suggesting about 25% success rate. However, I've been here 4 years and we haven't really had a bad, hot, dry fall yet. So I guess we're due for one. Some of the recent work, so, like I said earlier, cover crops have been shown and that you can plant those in the early stages of corn. And we know that rye is amazing at removing excess nitrogen. These are things that are fairly well reported in the literature, but every one of those papers have certain challenges with them. And some of these was looking at different planting populations. One of the big things with interseeding cover crops in a corn canopy and a soybean canopy, are you going to get enough light to them to be able to make them persist? If you've got some that have questionable survivability, are you going to get enough snow catch? All those issues come into play When we're starting to think about some of the later season planting work, which is not in this lecture, one of the big problems that we are dealing with, particularly with our small seeded crops like the oil seeds, is stover, the amount of corn residue out there. So there's several issues to work on this, but planting around the V5, V7 stage is probably one of the easier things to do. Now, you're probably aware that you can also aerial seed, but it's fast. But one of the issues with it is that we are getting some of the seed caught up in the canopy, and we're highly dependent on rain. That's a big one. There's also been some work done on directed broadcasting where this gets around the canopy problem. You can set up large overhead interseeders to be able to do this. It's not as fast as aerial, but still getting the seed to the ground. But one of the big problems that we see with this program is that it's largely broadcasted. And so we're thinking, well, could we add some incorporation into the system to help achieve better establishment? With better establishment, we're getting greater spring biomass production. Greater spring biomass production means more nitrate in the plant, which means less nitrate at the tile. So that's kind of the broader thinking on this. And we know, it's been well shown that seeds, good seed soil contact is important for germination of all plants. Now, you can cheat a little bit. Small seeded crops like some of your radishes and things of that nature would require a lot less incorporation than a large seeded crop like wheat or pea or even cereal rye for that instance. So this brings us into our broader perspective of this project. And so we wanted to go V7, and largely why I picked V7 was I was very conservative and worried about any corn yield loss. I couldn't, there's no way I'd be able to convince anyone to use this program if we were going to get corn yield loss. So I went at the roughly close to the end of the critical weed-free period in corn. We looked at 5 different cover crops, and I'll get into those in a second, and we looked at a couple different ways, or 3 different ways of establishing those. Really hoping that one of those programs would provide us a maximum biomass production in the spring as we rotate into soybean. So we did this using a high clearance drill. I think it's also called the Pennsylvania interseeder. We call it the blue planter. I don't know if that's what they want to call it, but we acquired one of these. Essentially, it's a drill 36 or 38 inches of clearance underneath it, and it has a skip row. And there's 3 drill lines per every 30 inches. So we're in 30-inch corn. We also decided, well, we're going to look at just directed broadcast. So we are able to use our drill to meter out seed, but none of the no incorporation. Or we had, and one of the other treatments, you can see kind of a drag that we built there to get some incorporation. So there's 3 ways of doing this. Each one of those had a bit of increasing incorporation throughout the system. We also were looking at 5 different cover crops. Winter rye, I believe most people are familiar with that. It's a cereal grain that is extremely winter hardy, produces lots of biomass, large fibrous root system. It's just it's a really nice cover crop to work with, relatively inexpensive. Red clover, we wanted to get some legumes in the system. Red clover is biennial. It fixes nitrogen. It does not have the winter survivability of cereal rye, but it is a bit better, let's say, a measure better than hairy vetch in terms of winter survivability. Hairy vetch is in there. It can produce a lot of biomass and also produce a lot of nitrogen in the system. But again, its winter survivability is very questionable. And until we release new varieties on it, I would not recommend using that in your system. And then there's pennycress. This is a domesticated crop that we're working on. It's actually domesticated from the field pennycress, which is typically seen as a weed in some of your forage production systems. This is a fast cycling brassica oilseed crop. So with winter survivability, not quite as good as winter rye, but a lot better than red clover. And then the last one here is this winter terminating mixture with of oats, peas, and tillage. Some people don't want to deal with residue issues when they're rotating into soybean. We as always, we track all kinds of parameters, but we had this kind of interest. We wanted to know if rye would allow us onto the field earlier, or would rye penalize the soybean. So the hypothesis was, would rye, cereal rye, which we believe would have been the best one of all those five in terms of biomass production, would it actually penalize the soybean production? Would we get a situation where we pull down soil moisture to the point where the soybeans suffered? And so in those plots, we monitored volumetric water content at 30 and 60 centimeters throughout the entire 3 years of the study. All of those plots were monitored. Now, for a bit more detail, so this was these were 6 replicates it ran for 3 years. We're finishing up the last year on soybean. Will be this year. It was positioned at the Waseca American Research and Outreach Centers. We have corn and soybeans. So the way it works, you start at V7. We have best management on corn. Ran weed-free with exception. There's no pre-emerge in the system. It's all post-applied glyphosate, largely because I'm at sites where I don't have to deal with herbicide resistance problems, and I just wanted to remove that factor altogether. Corn was managed based on best management practices. Cover crops would have been planted at V7 with those 3 different planting methods. The cover crops persist out there throughout the summer. We come in at the end of the year. We harvest the corn yield. We take biomass samples of the cover crops. We don't take soil extractable nitrogen. The cover crops persist. The ones that do persist over the winter. We come back in the spring, like around May. We sample the cover crops again. We drop sample soil again, and we burn down the cover crops and no-till plant soybeans. So that's kind of the whole package there. That's why we're looking at corn and soybean. We're looking at cover crop biomass, cover crop nitrogen uptake, soil extractable nitrogen, and soil moisture. And that whole package and we're looking for who's the big winner in that system. So again, let's review that. I'm looking at 3 different management practices for planting, either directed broadcast, which would have no soil disturbance, directed broadcast with some light incorporation, that says the light dragon, and then the max soil disturbance coming from the pipelines drilled. So this is what it looks like. These were planted. These were planted at the end of June, and this is what it looked like in September. And so you can see we've got hairy vetch, the winter terminating mix, red clover, and rye. The rye was already starting to etiolate some. They were under some light stress. But overall, this was a fairly good year for production of, I'd say most of our falls have been pretty decent for cover crop production. Fall biomass numbers. So this would have been the biomass that we had been taking before we had harvested the corn. This has been like in the end of September, 1st of October. And the biomass numbers aren't going to break any records here. So what you have here along the x-axis, you got hairy vetch, you got that winter mix, you got pennycress, red clover, and winter rye. The DBC is the direct broadcast. The DBC INC is the green one is the direct broadcast, and incorporated in the blue is the drill. And what we saw is that incorporation really mattered in the for the fall biomass production, where we're getting greater biomass production out of our drill plots than we are our directed broadcasted plots. However, though, so it's one of these things where it looks like we're like, wow, it works. When we fast forward to spring and come back to the same plots, this is what it looks like. So you got the red clover on the left and the hairy vetch on the right. And then we tried to keep as much of the corn stover intact by harvesting above the ear. When we come back into this to do all this sampling, we don't see the same effect. And so this would have been the spring cover crop biomass on May 15th. And we see that winter rye did benefit from the drill, but not a huge benefit, maybe 200 pounds of biomass per acre. Our small seeded crops like red clover, and I know hairy vetch is not essentially small seeded, but both of those tend to benefit from having some incorporation in the system. The field pennycress, it really didn't matter how you planted it. And I'd almost say the same thing for rye. Rye seems to be a bit forgiving as well. We're still getting 800 pounds of biomass out of that, even with the just the broadcast plots. Why do we want biomass? Well, because biomass, nitrogen uptake in the plant is a function of biomass production. The more biomass you have, the more nitrogen you were able to uptake and use. And winter rye at the time of termination had about 25 pounds, or you can think of pounds per acre or kilograms per hectare of nitrogen in that material. Red clover, roughly 20 pounds. So the trends are, because biomass is the nitrogen values are dependent on the biomass, so the trends are roughly the same. We are seeing, you're getting better biomass production out of having incorporation in the system, and as a result, you're getting a bit more nitrogen in those crops as well. But this is the piece that we're most interested in, because this is where, if we produce a lot of biomass, we should be able to see some kind of impact at the tile. So you have two sites here. It's a little busy, so I'll break it. You have Lamberton and Waseca on the right. And you have no cover crop, that winter hardy mixture, hairy veg, pennycress, red clover, and winter rye, and then it just repeats. And I want to draw your attention to the first node, the no cover plots, the arrows there. You see that no cover versus a winter rye reduced nitrogen at a meter, or 1.2 meters, across that soil profile by nearly 50%. And so where we would be losing almost 80 pounds or 80 kilograms of nitrogen per hectare, we only have about 40 pounds underneath the at Lamberton, and roughly a little less than 60 pounds at Waseca. So we know the rye, that was actually expected. What wasn't expected so much was to see we kind of expected to see a bit more out of the winter terminating mixture, but it really just didn't produce enough biomass in the fall. And if we think back to when the tiles and when the nitrate is flowing, it's really in the spring, and so not having biomass there or an active growing plant really impacted the service. Across the other cover crops, we see that each of these cover crops are providing service better than doing nothing, but cereal rye was the big winner for nitrogen reduction in the system. And so this is really just kind of capsulized, just kind of like it's kind of a capstone piece on it. So what it looks at is we have spring cover crop biomass along the x-axis here, and along the y-axis, this is the departure of nitrate concentration from the check. And what we see, though, as you increase your biomass production, we are going to get a greater departure from the difference between doing nothing, like best management practices, and having a plant in the system is going to be better. So the amount of biomass you have in the system is inversely proportional to the amount of this departure. So you want biomass in the system. Now, if we wanted to pivot at this point to, like, you could utilize that biomass for forage production systems. In ours, we chose to use it as a cover crop. So this is the other hypothesis we're trying to test, and I apologize, one of these, this is moved. This B should be up here on the slide here. So this looks at, this is a really busy figure, so I'll just break it down quickly. On this, I think you guys can see my mouse, but on this axis we have precipitation. On this axis we have volumetric water content on the second y-axis. And along the x-axis we have time. And then this shaded interval here, this is cumulative growing degree days for the cereal rye. The black bars indicate a rain event. So this would have been read off of this side. And in the solid line here, this was the winter rye, the soil moisture units in winter rye, and then the dashed one is the no cover crop check. Now we sampled this across all 6 site years, and only 1 year did we actually get this effect, where at the time that we terminated, we saw, at the time we sprayed the rye, we saw there was a difference between the rye plots and the no rye plots in terms of volumetric water content. However, rain events completely masked that as we came in and planted our soybean. So essentially, and I can't, it's not definitive, I'd say given the years, the wetter springs that we've had, the rye is not causing any problems. Now, if you got into a really dry spring, I think maybe we can actually see this effect maybe maximized. But under our data, only 1 out of 6 site years actually showed an impact of a reduced soil moisture in the system. So overall, what we saw across all 6 site years is there was no impact on corn yield. The corn yielded at or above our county averages. So that what I mean by no impact, when we looked at all the cover crop treatments and compared that to the best management practices, there's no statistical difference with it. The soybean is a little trickier. So overall, of the 6 site years, 5 site years we had no difference in soybean yield, with the exception of 1 year at 1 site, and that was at Lamberton, where we had some problems getting the hairy vetch under control with herbicides. And so that's one point I make a lot of times when I speak with people that want to get into cover crops. Have a plan to be able to terminate these things. Cereal rye or winter rye, if you catch it early, it's not a problem. Legumes, as they start moving into reproduction, can be really tricky to get them under control. So be sure that you've got a strong program in to manage that. But we only saw that in 1 year, and I believe they were all above the state average, or the county average. Now, this is the piece that I'm probably most interested in, because this ties back to the original why I chose 3 different ways to plant. And I farmed, and I realized time really matters. And so I was thinking through this, like, what happens if those drilled plots, that fancy drill that I have, yielded the same amount of biomass, or at least equivalent benefit as a broadcasted plot? Well, what it suggests, if that's the case, and we see that they're fairly close in the data, it asks the question, do you need a drill? Maybe you can get by with planting, with broadcasting or directing your broadcast and so on. And so I really wanted to dig into this, ask this idea where we can talk about cost, planting cost, speed, amount of acres per hour, and roughly the benefit of the realized benefit. Now, this was just a pilot project. We've gone back in and redefined benefit for the publication, but this is kind of the idea. And so what we've done, I was thinking, well, okay, we'll think of this in terms of a triangle with 3 vertices. And so these would be your vertices: cost, speed, and benefit. And you've got your directed broadcast, your broadcast incorporation, and your drilled. And you see the benefit largely is pretty close if you only think about spring biomass production, which is not a very it's not a very robust benefit. We're reworking that. Cost, well, it's roughly all costs about the same. The speed, look at the speed. The drill is the slowest one, the directed broadcast being the fastest one, and speed matters. When we were thinking in terms of the actual cover crops, the cost per seed is now more variable because certain cover crops are more expensive than other ones. However, when we look at the benefit, really cereal rye was one of the best biomass producers, and it wasn't the least expensive, but it was one of the well, let me rephrase it. This gray triangle has the largest area than the other 3, because we're really comparing area and not just where they end up on the vertices. So, but rye overall was providing, under this very simplistic way of thinking about it, was providing the best benefit. It really didn't matter how you planted it. And that's one of the nice things about the cereal rye in the program. So summary: corn grain yield, solid yields were not affected by cover crops. Soybean yield only at 1 site. We saw some due largely to the persistence of the hairy vetch. Planting methods established greater seed soil contact. We saw greater overall. We're seeing greater impact to biomass production and spring uptake when you have more incorporation in the system. However, we did not ask the question: is the broadcast one enough? Maybe you could be happy with just 500-600 pounds. Maybe that's what that kind of those triangles are supposed to help us identify. Cover crops decrease soil nitrate, especially when in rye. We're seeing about 50% reduction when compared to our best management program. The efficiency, we see in that largely the broadcast is the fastest one, and speed really matters in those. And then, hairy vetch seed cost also matters. That's why we lean more towards our cereal rye with those. Now, I've got a few more minutes. I want to pivot over into another program, and which is essentially still cover crop related, but it's cover crops largely for economic opportunities. So we get all of the many of the ecological services that are covered in the past slides, but now we're going to be looking at being able to harvest the crop, and that I don't mean just for forage, I mean for actually another grain crop. And so when you ask farmers, this is a SARE CTI survey, and when they ask farmers who grow cover crops, what they wanted out of the cover crop, you can see a whole list of these here. And I was surprised, only 17% of the respondents recognized cover crops for providing economic return. Now, I didn't see the question. Maybe it was largely around haying and grazing and animal so it could be that's why it was lower. But when I was thinking, when we farmed, if it didn't make money, we couldn't do it. It was always a real struggle. And so in the dairy operation, we were continuous silage corn, and we always had cereal rye following. In the fall, the cereal rye would have been green shop. We had a way to export the cost and produce more milk, feed our animals as stores became a bit lower. And I think that storyline is quite well known in most systems that have integrated animals in it. But what about that 8 million acres of corn and 7.5 million acres of soybean? What could you do for those people? In addition, with helping the people with that have integrated animal production systems, and that's where we brings us into the green program. And so what this is development of new germplasm, new crops for the upper Midwest, largely to enhance our water resources. There's a whole list of these. I'm not going to go through all of them. I'm going to focus predominantly on the 2 oil seeds, pennycress and camelina. And the reason why we're interested in these is that they're extremely cold tolerant. They are rapid seed maturity, so they cycle quickly, which means that I can plant them in the fall and I can harvest them early summer and still get another crop planted behind them. There's also a lot of interest in terms of their oil content, both food and for bioproducts. We have some partners that are interested in it. We're working closely with the Agricultural Utilization Research Institute, AURI, or AURI, for extracting oil, fiber, protein to figure out what are these new products, General Mills, PepsiCo, and so on. And why we're putting so much energy in this is because we know that we know we had to have an economic pull to enhance adoption on it. And so my kind of thinking is if we can plant these oil seeds, or whatever they are, it doesn't really matter if they just happen to be oil seeds for this program, and not displace your corn and soybean production, still produce full season corn and beans, there's a good chance that you will adopt that technology if we can provide the markets. And so that's why we're working hard to develop not only the germplasm and the agronomy around, but also the supply chain and the markets for these new crops. So this is how it works. So you'll remember this slide to the right there that was looking at how we can have cover crops persisting over the winter and the spring. So what we do is we come in, we can either relay crop it or we can double crop. Relay is not a great name for it, but essentially what that is stating that the oil seed is living with the soybean. They share time in the calendar together. We're in a double crop system. They do not share time in the calendar. You harvest the oil seed, you come back and plant soybean or some short season crop behind that. We're evaluating 14 different double crop opportunities behind the oil seeds, whereas largely the relay crop is only set up largely for soybean production systems. There's an easy way and a hard way to do this. The easy way is to come in late August, September behind corn silage or small grains and plant up the oil seeds, use your favorite planting method. And then they persist throughout the winter. We're getting all of those services to the extractable, just like I shown in the previous lecture. And then come into the spring, we no-till soybean right on top of them. And then in May 31st, believe me, there's soybean underneath that. We're getting pollinator resources. We're getting protection of soil water resources. And then in June, you can see there's no weeds in that plot. And it's not because that they were sprayed. It's that the oil seeds are over-competing for some of those early established or early emerging weeds. We harvest off in June 17th or so, and you can see the soybean right underneath the crop. That's the easy way to do it. There's a really hard way to do it. And this one the setup, most of the setup is the same. It's just we're coming in around R6, late August, early September in corn, using high clearance equipment to seed up the oil seeds, harvest the corn. They persist throughout the winter, and then it goes back to soybean. The problem with the hard way is that we're dealing with lots, 4 to 5 megagrams of corn residue. And so we're having to try to figure out what are some of the strategies to manage some of that corn residue so we don't smother our secondary crop in there. But if you follow wheat, corn silage, even sugar beet, a couple of those crops where they could be off the field early enough, you don't have that problem. We're facilitating a lot of this, not just with the oil seeds, but a lot of my program, maybe the slide should have been earlier, a lot of this is done, the high clearance work is done for the oil seed system is with this red interseeder that we acquired. It has a Gandy orbital air seeder on the back that they provided from us. And then we're also collaborating with a company here in Minneapolis that's looking at deploying robots to do some of the seeding with it. This is why we're interested in, I think this is my last slide, or last two slides. This is some data that was of the oilseed program, and it wasn't published. It's actually published by Gesh et al. There's a typo on this, not Nolan et al. And what Gesh et al. Found was, and they focus on the left panel here. So they have a monocrop soybean producing 50 bushel an acre, okay? And then they have these other treatments here where they have camelina, and camelina is another one of the oilseeds that we're working with. And what you see, you do get a reduction of soybean yield, right? You can see the 42, 39, 27, so on. But if you look at the total, at least with these two treatments here, we're getting above the total production of just soybean alone. Even more so importantly, because what we're after in the oil seeds is the actual oil, the products. Well, the meal is valuable too, but a lot of the goodies oil. So their monocropped oil system, your monocrop soybean giving you 80 gallons of oil per acre. But what you see with the inclusion of camelina, which is these red bars, we're producing far more total oil out of the system, complementing the soybean oil system. So that's why we're interested in it. It's if you want to plant corn and soybean, that's great. Plant corn and soybean. Let's get a crop in there that can provide ecosystem services and be able to harvest as a second harvest in the year. I've always, most of everything I talk about is at the Forage site. You can write down the actual address, or you can just search UMN Forages. I put my presentations in the Forage presentation section. I also have a Forage quarterly newsletter. I put forage, cover crop. I just kind of lump it all together. So I'd highly recommend you to sign up for that. And with that, I think we're at the end of the lecture, and we'll open up for some questions.
Thank you, Dr. Wells. We have a few questions here. For those of you who have questions, please go to the chat icon up on the top or on the bottom, either or, and click on that and type your question in. A couple questions here to get us started. Is the 1936 Sprague publication available online?
No. Well, I don't know.
Okay.
I don't know. It was given to me in a stack of, a faculty member was cleaning out it was a stack of just folders. So I don't know. Maybe it is.
Okay. Next question. How much nitrogen?
I just took a picture.
Okay. Okay, very good. I suppose in your spare time you could have a work study, copy that thing, and download it as a PDF, huh? Someday. Is that a big publication? Is that a big publication?
It's a little paper. It's
a little paper. Okay.
No, I don't know. Maybe 15, 20 pages tops.
Okay. Next question. How much nitrogen fixation can we expect to see with interseeded legumes such as the red clover or hairy vetch?
A very small amount. If you look at the data, we only have about 25 pounds, 20, 30 pounds of nitrogen in the above ground material. So it would be, say, 2/3 of that value could have come from the atmosphere. And the rest of that would be coming from, from the roots in the system. We saw roots in the red clover at 90 centimeters, where the roots went all the way down to 120 centimeters. So we're terminating those we're terminating even the clover and the vetch in the system are being terminated earlier than what you would have done in, say, a more southern location where you could produce 200, 300 pounds of nitrogen in the. We just don't have the growing units to really realize the nitrogen benefit of legumes in terms of full season corn and soybean production system. You want to plant something else like corn and plant it late, then yeah, you can do that. If you want to plant into maybe dry some of that nature, you could probably do that. But if you're going to plant 100-day corn or 2.0 beans, you're going to have to terminate before you get a lot of those benefits from the legumes.
So that leads into our next question. What about slightly shorter day corn or soybean varieties to pick up a week or two on the growing season?
Yeah, that's a great question. And we're doing that now. We have a program after this lecture. I got to run to the field where we're planting 1.7 and 1.5 beans behind double cropped oil seeds. So yeah, you could do that. We think that. See, one of the things I haven't talked a whole lot about the oilseed program that we're using right now is not necessarily a development crop. The new lines now are up to 2 weeks earlier, and so when you're counting every week in a double crop scenario, 2 weeks can mean a big deal. And then we're coupling that with desiccants right now, so maybe we could be even 3 weeks earlier. So then we could be planting 2.0 beans behind a double cropped pennycress and camelina system. But then in all of our work relaying, those are full season beans related right into the oilseed. Now, getting back to your question about maybe shortening the cycle on, say, for the fall, you can plant shorter season corn crops, shorter season crops. But the problem I can see that you'd have to carry your economics across the soybean meal. If you did see yield reduction to shorter season relative to maturities, how would you recoup that money in the corn year? But yeah, I mean, there's a lot of opportunities for these programs.
Next question: what clover varieties seem to work the best?
Yeah. Well, that's another good question. We haven't looked at a large range of clover varieties. I would say don't count on your clovers right now. There's some breeding work going on at the University of Minnesota to increase the winter probability, and we have seen mixed survival. So the hairy vetch has just been kind of abysmal for the winter survivability. The red clover has been more mixed, but when you're in a state where you can kill alfalfa, and alfalfa is far more winter survival than or winter hardy than red clover. So most of my programs now I'm not focusing on the legumes until the breeding catches up with their varieties. So to answer the question, I haven't assessed we haven't done a variety panel on clovers, largely because there's very few of them that reliably survive the winter forest. We have looked at Kura clover and we have looked at red clover, or the medium red, and those seem to do okay. I have looked at some birchwood trefoil and a few others, but I'm pulling back from the legumes until the breeding catches up.
Okay. Next question. Are these or how are these research results getting distributed to corn and soybean growers?
So there's a couple of avenues. We use the Crop News blog, and so you can just search UMN Crop News. That is, if you're working in corn, soybean, or any of the mainstay crops, you really should be attuned to that listserv or that blog, because everything comes through there. We also do a lot of winter education. This could be meetings like this, but in person. So there's face-to-face. We do some mailing and then large field days. We have one coming up September 9th in Rushmore. I think that's right. Yeah. So I mean, there's a lot of avenues to release. And if you really want to get some late night reading, go to agronomy journal or crop science, pull down one of those papers and lull yourself to sleep reading those.
Okay, this is kind of a comment, but just for discussion's sake, I had a personal conversation with some people who've been working with aerially seeded covers in late summer on corn, and from about 10-15 years ago, and they were having a lot of difficulty with establishment, and the thought was, as you stated, that it was a weather related issue, but they went back and did some looking, and they think a large part of the issue was herbicide residue causing that. They actually went back to individual fields and traced back herbicide history on those fields, and they felt that the herbicide could have been or may have been as big of an issue as the weather was. And that's just an observation I heard this spring from some people who've been working on things down there, and wondering if you had any further insight on that.
Yeah, so this is I think some people thought this was a blind spot of our program, but so we're now to the position to start looking at the whole wheat package, and pre-emerge herbicides are going to be a part of this program. And we showed that you can plant at V7, V5. We never answered the question, should you do it? Mm-hmm. And I think the V5, V7 planting dates are going to be a bit trickier, particularly when you're looking at herbicide weed resistance. We have a study that they're rolling out this fall to look at, we haven't acquired funding for it yet, but they'll look at a range of pre-emerge herbicide programs that are well used in the consortium systems. And the idea is that there would be enough half-life time, they have a short half-life, that we could come in September. But what we went through and picked a series of them that we thought that had the possibility of not causing us problems, but we have never tested that in the state, and we definitely need to. And the other problem is testing that kind of activity. It's easy to say, oh, it was probably the pre-emerge, and it could actually be, but to get reliable information, to be able to make predictions, if I sprayed my pre-emerge this day and it rained this much on this soil type, would I get that effect? And I converse with science groups. That's a tricky thing to get a handle on. So we want to start doing that, and that'll roll out this fall, and we can start integrating directly into IPM herbicide weed management group. And there's a strong group that does that in Minnesota. I think it's probably rain, but I guess it just depends on what herbicides they used.
Yeah, complex set of things to look through there. Another kind of comment, this is more for the group. Your focus was on, of your research, was primarily on establishing covers in corn and bean systems for a large part, the impact on nitrate sequestration. I know there's a number of participants today who have livestock, and just a comment is, the seeding methods, we saw some variances there on, how much biomass production you were getting in the spring versus the fall based upon seeding method. And I just want to remind folks, think about your goals. Think about what are you seeding this cover crop to accomplish? If it's primarily for nitrogen sequestration and to keep weeds down and things like that, that's a far different goal than feeding those livestock in November and December. And so that would have a definite influence on your seeding methodology, it seems like, from your work.
Yeah, no, I agree. And it's less apparent probably in this work than the future work, where we're looking at the oilseed. I want to harvest a crop. I need numbers. I need good populations, good stands, which is the same thing that you would need if you're feeding animals in the fall or the spring. You want a lot of material out there. One of the big pieces is killing us dealing with the corn stuff. It's just 210, 215, 220. It becomes really problematic, particularly with small seeded cover crops, to be able to handle that. The grasses can deal with it, but the brassicas and clovers, they really don't do well in that environment.
Well, great. Well, thank you, Dr. Wells. I see we are at our time for 1 hour, and I thank all of our participants for showing up today. We have recorded this. We will be uploading it on our SFA website here in the future. So we covered a lot of ground today. And again, thank you for joining us. Thank you, Dr. Wells. And I know everybody's chomping at the bit to get out and enjoy this beautiful day. So everyone have a good day. Thank you.
Thank you.